Welcome to Homework Lib.
Hi, so for this problem what we're going to do is employ the ideal gas law that tells us that P, pressure times volume, is equal to the amount of mole times the gas constant times the temperature. So the value for M is going to be equal to pressure times volume divided by R times T. And what are the data points that we're going to use? In this case, I'm just going to pick the value at temperature equal 80.6 degrees Celsius. That is giving a volume of 5.9 milliliters. These 5.9 milliliters correspond to 5.9 times 10 to the minus 3 liters when we transform from one to another. Remember that whenever we're doing this kind of calculations, we need to transform the temperature and the volume into the corresponding units that appear on our gas constant. So for example, the value for R in the most convenient units that we have, it's going to be 0.082 liter times atmosphere divided by mole Kelvin, right? So that means that our pressure needs to be in atmosphere, that is already given to us, 1.2 atmosphere. The temperature needs to be in Kelvin, so you simply need to add 273.15 to our value. That gives us a temperature of 353.75 Kelvin. And these values are the ones that we can plug in directly into our equation. So now the value for N, it is going to be pressure 1.2 atmospheres, volume 5.9 times 10 to the minus 3 liters, divided by R, that is 0.082 liter atmosphere divided by mole Kelvin, times the temperature in Kelvin, which is 353.75 Kelvin. Before we do any operations, you can verify that the units cancel out properly, liters and liters, atmospheres and atmospheres, and Kelvin with Kelvin. We have mole to the minus 1 in the denominator. That means that our final result is going to be in mole directly. And the result is 2.44 times 10 to the minus 4 mole of substance that we have, of the gas that you have in this syringe. And that would be all. Thank you very much.